heat. It is by means of them alone that we see anything. When the room was dark, you could not distinguish the table, the chairs, or even the walls of the room. Why? Because they had no light waves to send to your eye. But as the sunbeams began to pour in at the window, the waves played upon the things in the room, and when they hit them, they bounded off them back to your eye, as a wave of the sea bounds back from a rock and strikes against a passing boat. Then, when they fell upon your eye, they entered it and exited the retina and the nerves, and the image of the chair or the table was carried to your brain. Look around at all the things in this room. Is it not strange to think that each one of them is sending these invisible messengers straight to your eye as you look at it, and that you see me and distinguish me from the table entirely by the kinds of waves we each send to you? Some substances send back hardly any waves of light, but let them all pass through them, and thus we cannot see them. A pane of clear glass, for instance, lets nearly all the light waves pass through it, and therefore you often cannot see that the glass is there, because no light messengers come back to you from it. Thus people have sometimes walked up against a glass door and broken it, not seeing it was there. Those substances are transparent, which, for some reason unknown to us, allow the ether waves to pass through them without shaking the atoms of which the substance is made. In clear glass, for example, all the light waves pass through without affecting the substance of the glass, while in a white wall the larger part of the rays are reflected back to your eye, and those which pass into the wall by giving motion to its atoms lose their own vibrations. Into polished shining metal the waves hardly enter at all, but are thrown back from the surface, and so a steel knife or a silver spoon are very bright and are clearly seen. Quicksilver is put at the back of the looking glasses because it reflects so many waves. It not only sends back those which come from the sun, but those too which come from your face. So when you see yourself in a looking glass, the sun waves have first played on your face and bounded off from it to the looking glass. Then, when they strike the looking glass, they are thrown back again onto the retina of your eye, and you see your own face, by means of the very waves you threw off from it an instant before. But the reflected light waves do more for us than this. They not only make us see things, but they make us see them in different colors. What, you will ask, is this too the work of the sunbeams? Certainly, for if the color we see depends on the size of the waves which come back to us, then we must see things colored differently according to the waves they send back. For instance, imagine a sunbeam playing on a leaf. Part of its waves bound straight back from it to our eye and make us see the surface of the leaf, but the rest go right into the leaf itself, and there are some of them that are used up and kept prisoners. The red, orange, yellow, blue, and violet waves are all useful to the leaf, and it does not let them go again. But it cannot absorb the green waves, and so it throws them back, and they travel to your eye and make you see a green color. So when you say a leaf is green, you mean that the leaf does not want the green waves of the sunbeam, but sends them back to you. In the same way, the scarlet geranium rejects the red waves, and this table sends back brown waves. A white tablecloth sends back nearly all the whole of the waves, and a black coat scarcely any. This is why, when there is very little light in the room, you can see a white tablecloth while you would not be able to distinguish a black object, because the few faint rays that are there are all sent back to you from a white surface. Is it not curious to think that there is really no such thing as color in the leaf, the table, the coat, or the geranium flower, but we see them of different colors because, for some reason, they send back only certain colored waves to our eye? Wherever you look, then, and whatever you see, all the beautiful tints, colors, lights, and shades around you are the work of the tiny sun waves. Again, light does a great deal of work when it falls upon plants. Those rays of light which are caught by the leaf are by no means idle. We shall see in Lecture 7 that the leaf uses them to digest its food and make the sap on which the plant feeds. We all know that a plant becomes pale and sickly if it has not sunlight, and the reason is that without these light waves it cannot get food out of the air, nor make the sap and juices which it needs. When you look at plants and trees growing in the beautiful meadows, at the fields of corn, and at the lovely landscape, you are looking on the work of tiny waves of light, which never rest all through the day in helping to give life to every green thing that grows. So far we have spoken only of light, but hold your hand in the sun and feel the heat of the sunbeams, and then consider if the waves of heat do not do work also. There are many waves in a sunbeam which move too slowly to make us see light when they hit our eye, but we can feel them as heat, though we cannot see them as light. The simplest way of feeling heat waves is to hold a warm iron near your face. You know that no light comes from it, yet you can feel the heat waves beating violently against your face and scorching it. Now, there are many of these dark heat rays in a sunbeam, and it is they which do most of the work in the world. In the first place, as they come quivering to the earth, it is they which shake the water drops apart, so that these are carried up into the air, as we shall see in the next lecture. And then remember, it is these drops falling again as rain which make the rivers and all the moving water on the earth. So also it is the heat waves which make the air hot and light, and so cause it to rise and make winds and air currents, and these again give rise to ocean currents. It is these dark rays again which strike upon land and give it warmth, which enables plants to grow. It is they also which keep up the warmth in our own bodies, both by coming to us directly from the sun, and also in a very roundabout way through plants. You will remember that plants use up rays of light and heat in growing. Then either we eat the plants, or animals eat the plants and we eat the animals. And when we digest the food, that heat comes back in our bodies, which the plants first took from the sunbeams. Breathe upon your hand and feel how hot your breath is. Well, that heat which you feel was once in a sunbeam, and has traveled from it through the food which you have eaten, and has now been at work keeping up the heat of your body. But there is another way in which these plants may give out the heat waves they have imprisoned. You will remember how we learned in the first lecture that coal is made of plants, and that the heat they give out is the heat these plants once took in. Think how much work is done by burning coals. Not only are our houses warmed by coal fires and lighted by coal gas, but our steam engines and machinery work entirely by water which has been turned into steam by the heat of coal and coke fires. And our steamboats travel all over the world by means of the same power. In the same way, the oil of our lamps comes either from olives, which grow on trees, or from coal and the remains of plants and animals.